Hello there. I'm super pumped for today's episode of AI Guide to the Galaxy because in our studio we have the true giant of the industry, the one and only Rod Johnson. From his experience in, I don't know, more than several decades in Java, from the creation of Spring Framework um, to helping the industry now create better AI agents and understand how to do AI agents better. We're going to talk about AI, of course, but it is my true pleasure to introduce and present to you Rod. Rod, how are you doing today?
Oh, I'm doing very well. Great to be here.
Uh, awesome. So you've lately, you've done all the industry revolutionizing stuff several times, and now your current spin is Embabel, which is the agentic AI agentic application framework for the JVM, based on your experience with Spring, based on your experience with how to create enterprise grade actual production level software. Um, can you maybe tell us a little bit first what motivated you to create Embabel and how would you describe it like as in a short elevator pitch?
So I guess I'd already been quite interested in machine learning for a number of years. And then when we got that amazing moment when suddenly, GPT-3 became actually good, and instead of spinning off down some rat hole, actually gave good answers. I became pretty much obsessed by how you could take that technology and make it useful for business. Thinking about, sure, for the personal assistant use case, it's pretty compelling, almost out of the box. Certainly, you give it a few tools and it's pretty compelling. But how do you build business processes on it that are repeatable, reliable, cost effective, safe? And that really scratched the itch that I've always had around programming models and how do you create a framework that enables people to do this effectively. I started, like a lot of people around Gen AI, I started in Python. And believe it or not, this is probably as of 2 years ago. My Python at the time is much, much more fluent than my Java because they've been writing Python daily for years and hadn't written Java for quite some time. And I fairly quickly came to three conclusions. Firstly, that Python is not a great language for building complex software. Secondly, that there is no special reason whatsoever that you should do Gen AI in Python. And thirdly, to unlock business value, you have to go where the business value is. So you need to have zero friction to access the business logic and the infrastructure that already exists. So, for example, if your business logic is in Java, if it's in .NET, if it's, say, on Node, that's where you want to build your Gen AI applications. You absolutely don't want to do a stack jump. So, having said that, the fact is that Java is number one of those three things in terms of business value that's out there, particularly in enterprise. And also, I kind of know a bit about the JVM. So, yeah, it just suddenly struck me that the obvious thing to do was to build a framework for the JVM. So I built on top of Spring, on top of Spring AI, and frankly, I think the result is a programming model that is significantly superior to anything in the Python world.
Right. So just to clarify, when you say like you need to, when you want to build AI into like actual industry and enterprises, and you need to meet uh the ecosystem where the value is, you mean people wise, not application wise, because on application level, AI is just integrating external systems, right? So technically, you could build it in Python, but to enable enterprise teams, which are normally JVM based or .NET based, you need to meet them there.
Well, I think it really depends on what are the assets that your Gen AI is talking to. And sure, every blog demo out there is using Brave Search or weather services or all these
Yeah.
things that are kind of cool. But the fact is, if you want to get it business value and say it's coded in Java or .NET, you are going to have to get it up. Obviously, you could put some kind of interface on it, like a REST interface, or maybe expose it as MCP tools, but already you'd have to be using the JVM to do the latter of those things. But I think the missing piece here is domain modeling. So real world value is delivered in the enterprise by true understanding of the domain. And that understanding of the domain exists already in, code that is developed over years and years of experience. So I think you need really high fidelity between the prompts you're sending to the model and the structured returns you're getting from the model and your domain model. And then when you think about that, the idea of having a language jump unnecessarily in there is clearly going to lose a lot of fidelity.
Yeah, yeah, that makes a lot of sense. So, um, when 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 Spring Framework was coming up, right, there was a very core principles of, well, you wanted like a lightweight programming model with components. You wanted dependency injection to be the kind of sort of the core concept for this. Uh, is there something like this in Embabel, or would you say it's just a like a sum of the parts where it's just many small things that make it good?
No, really, I think there are some pretty big ideas behind it, and they combine together, hopefully, as with Spring, to make a coherent whole. So, firstly, obviously, it is on the JVM and it's fully leveraging what we have on the JVM, which already gives you with Spring like far superior configuration management than you see in the Python world. I mean, it's just better. So that's one thing. But then there are two other key ideas which I think are very important. Well, actually, directly following on that, there's the fact that we heavily emphasize type safety. So, if you're working in a strongly typed language, you should fully leverage that. Even if you look at some of the other Java frameworks, they're actually not, they don't seem to have gotten that memo. So you're seeing like magic string keys in templates. We don't do that at all. Everything is strongly typed. And that, of course, minimizes your potential for error. And there are two other key ideas. The second is the idea of a planning step that is deterministic. So to do complex workflows, you need more than one LLM interaction in many cases. In fact, very often you're using different LLMs for each interaction. You also need interactions that are actually just calling code rather than an LLM at all. So, one way you can address that is to just expose everything as a tool. Like throw a bunch of MCP or other tools at your model and let it figure it out. That works well in certain cases, but it is nowhere near reliable enough to automate business processes. So that is where Embabel introduces the idea of a deterministic planning step. So sure, you can give your LLMs tools, you can do all the same kind of things you can do in other frameworks, but we have the ability to express multi-agent workflows through planning. So instead of just relying on the LLM to work out how to chain things, we model the world in terms of actions and goals. So when you try to do something in Embabel, it maps onto a goal. A goal has certain preconditions that must be true. Then our planning algorithm, which is an A-star planning algorithm, so deterministic non-LLM AI algorithm, looks at the preconditions and postconditions of all the actions that the system knows about and works out a path that can get you to the goal. This has a number of advantages. Firstly, it can explain why it did what it did. Secondly, it's deterministic. And thirdly, even if it sounds complicated, in practice, the action chaining is driven by data types most of the time. So the developer doesn't really need to think about it, but they still get the benefit that the system will do the same thing each time it runs in terms of planning multi-agent steps. So I think that is an innovation. There are some other frameworks like Microsoft Semantic Kernel that do planning, but they use an LLM to plan. And as soon as you do that, you're obviously losing determinism. So, there definitely is, I think, a key innovation there in Embabel. And my goal was certainly not to like play catch up or imitate what's in Python. I would not be interested in doing that. My goal was to create the best agent framework in the JVM. Finally, we have a lot of emphasis on domain modeling. So, we encourage people when they think about building their agents, they should start by thinking about their domain model. It's like good software engineering. And it is pretty amazing. Once you get the domain model right, your agents kind of very often naturally fall out of that. And you get a lot of reuse and a lot of productivity in building agents.
That sounds sensible. Um, can you maybe show us an example of an Embabel agent and show this concept in the code? Um,
Certainly. So what I'm going to do is show you our Java agent template. I shall just get the right window up and I shall share my screen. So here we have one of our repositories on Embabel at GitHub. This is the Java agent template. Easiest way to get started with Embabel if you're using Java. So all you do is just go to this, use this template, and it'll create a repository in your own GitHub account. We also have a Kotlin agent template. But so I've already got this cloned. So let me just bring up the default form factor of this, which is that we start under Spring Shell. Obviously, in production, use of Embabel, you're going to be in a web application or a message application or some other form factor. But for development, the interactive Spring Shell is really cool. So here, when it comes up, you'll see that it detects models which will depend on the API keys you give it. So I have given it here Anthropic and OpenAI API keys, and it's detected it's automatically deployed the most popular models. You can configure all that in code. You can add any model that's supported by Spring AI, which is just about everything. So by default, it is configured by using Spring Boot. So let's just go to sorry, it's a bit hard to work out how to do this with a small screen. So let's go to the Java source and we will find the application class. It's a Spring Boot application class. Obviously, if you create your own project from this template, you'd rename the class. But, very, very straightforward. All we need is at Spring Boot application and at enable agents. And so at enable agents automatically causes the Embabel processing to occur. To get this running, this is actually a Maven example, but of course it runs as well in Gradle. So here we're just using absolutely vanilla Spring Boot parent, latest Spring Boot parent, and we have just added 2 of our starters to get going. So, particularly if you're familiar with Spring Boot, getting going is really easy. So there is one agent already deployed. So we can ask the shell, how many agents does it know about? And it says that there's an agent that will generate a story based on user input and review it. There's a lot of the planning information here, which we don't need to go into first. But let's firstly have a look at the code, right? And review agent. So you can see that we've got an @agent annotation here. This causes Embabel to load the agent metadata from looking at that class. Also, it is a Spring @component annotation. So Spring is also going to inject this. So it's a special Spring component that is also an Embabel agent. So here, therefore, Spring is capable of injecting this. We get that from our configuration if we want to externalize it. And we now have a number of annotated methods. So the first one here is @action, and it's craft story. So let's look at this in a little bit more detail. At action says to Embabel, this is one of those actions. Remember, we've got actions and we've got goals. Actions will be chained together to achieve a goal. So this says this is an action that you could use, and you can see the preconditions here are going to be inferred by the parameters. So we need a user input and we need an operation context, which is a special framework thing that enables us to run prompts. So here we've got a nice fluent API for saying with LLM. In this case, we're using an automatic LLM, and we're setting the temperature hyperparameter. We're setting a prompt contributor to give it a persona. And then finally, we're calling this prompt. By default, prompts are constructed in Java or Kotlin code. You can also externalize them in Ginger templates. But one of the major benefits of not just Embabel, but any agent framework, is that it encourages breaking up longer workflows into smaller action steps. So as you can see, this is a pretty short prompt. So given that Java and all modern languages have multi-line strings, if you do it here, you get type safety as well in terms of what's exposed in building that string. So typically, you build your prompts right here, which means that if you refactor, for example, the name of the word count or whatever, your prompt isn't going to break.
Yep.
So that is the first action. To execute this fully, Embabel needs to know about a goal. So there's another action here that reviews the story. Notice it takes the story and the user input, as well as the operation context. So this, Embabel can work out that this action can only run after a story has been created. These are very simple domain types. So the story and reviewed story are both records. Either your domain objects can very often be types you've already got. You can use them. Like, for example, you can even use, say, JPA entities or things that already model your domain. Or in a net new application like this, they're typically going to be Java records. And so here, this achieves goal annotation says that this actually will achieve the create and review story goal. So now when we run this, we can do, what do we want a story about?
About a line running.
Okay, how about a story about what was it?
A line running around to splashing people with plutonium.
Okay, now that's left field. So firstly, it's going to choose the agent based on user template, a user input. This output explains the planning. But let's see, what did we get in a neon lit city? LLMs generally try to put a nice spin on things. Like, I don't know, they've somehow glossed over the fact that this is not a nice thing to do. This is possibly not a nice line. But hey, I'm not responsible for the LLM. So you can see those two steps ran. And interestingly, at the end, one of the things that Embabel does is track the invocation of every LLM it uses, and where possible, work out the cost of that. So we have access to an LLM database that gives us the input and output token cost. So to see how this ran, let's run it again and get it to show the prompts and be more verbose. A line running around and splashing people with plutonium.
I'm sorry, I don't know why I asked that.
And don't make it a feel-good story. Okay, and now I'm going to do -P, so it's going to show us the prompts. So, and we can go back over this in a little more detail. So, the lion prowled. Oh, this is much better. I like, yes. Oh, beautiful. Much better. We've no longer got a feel-good story. So let's go through the output here. So the very first thing it did was try to find an appropriate agent. If you're using it in production, you're typically asking it to achieve a goal explicitly because obviously we love determinism. But in this case, what it's doing is looking at all the goals it knows about and saying, okay, what does the user seem to want? Well, they clearly want to be told a story. So therefore it hits on the story goal. One interesting thing about this whole goal and action thing idea is that it's extensible without modification. If you look, for example, at the way, say, Crew AI in Python or LangChain or LangGraph model workflows, they wire things together, right? For example, in LangGraph, it's a state machine. That tends to be fairly hard to change, right? To change that, to add additional functionality can be quite difficult. In this case, although planning is deterministic, we can add more actions, add more goals, and potentially enrich the behavior. So it chose the agent, and it was pretty confident about choosing the agent. In this case, you use an LLM to choose the agent. So now it has created an instance of the agent, and the very first thing it's going to do is plan. So here it has formulated a plan. So remember, planning's dynamic. So it's said it can call a craft story goal, then it can call the review craft story action, then the review story action, and then it will have achieved that goal. So now it runs the first action, which means that going back here, the first thing it's going to do is call this. So you should see something relating to that. So what do we see? So the auto LLM resolved to GPT-4.1 mini, and here is our prompt that included our user input. Notice there's some extra stuff here. And the extra stuff comes from the persona. Remember we said with prompt contributor, personas writer. And also we've got the knowledge cutoff and the system date. They have both automatically been put in by the framework. So, when you use, say, Claude or ChatGPT, there's about a 3-page system prompt that includes lots of things like today's date. So if you call it directly with the API and don't put some of that stuff in, you will, for example, tool use, when we get to that, will be a real problem because it won't know whether it needs to search related to the current date. So, Embabel takes care of putting some of these things in so you don't have to think about it. So the prompt responded with a story object. How did it know to respond with a story object? Because it used the create object method. And we specified story.class. So we build on top of Spring AI, and Spring AI handles like generating JSON schema, passing it to the model, getting the type back. So in general, we strongly emphasize both strongly typed, prompt building and getting typed responses back. It generally, because there's a whole bunch of benefits in having that kind of structure. Okay, so we received the LLM response, and now it's going to replan, but you can see that the world state that is assessed, which in this case is based on the data types, is now different. So we started off with the world state. We had nothing set but user input. In this case, the world state is that we've run has story, and we've actually got a story object. So when it plans, it now sees it only needs to do one more step. The benefit of planning after each action is executed is a precondition is absolute. An action cannot run unless all its preconditions have been satisfied. A postcondition is kind of a promise of a side effect. So, maybe it didn't work, in which case it might be possible to replan and find another route to the goal.
And for example, if it would run that action but not create this story, like we would have the action run, but we would not have the story, and then the planning algorithm could potentially figure out like a workaround or something else. Okay, got it.
Exactly. So the cases where that's important is where you have an error-prone operation, which you might retry or you might have to reread around, or alternatively, when you need human in the loop, right? Like maybe something requires human intervention, and the agent process would go into a wait state until it gets what it needs. So this is where it's probably worth noting how the agentic part differs from something, say, like Spring AI or LangChain. So the agentic part is maintaining a process. So it's maintaining state across these multiple interactions. So, it's partly a workflow engine. So the this uses a different persona, and also it's obviously got access to everything there from the story. So, for example, we've put in the story text as well as user input, and at the end of it, it spat out the output. So that is probably the simplest possible example of an agentic flow. Also, in the Java agent template, there's something that is even simpler, which is the simplest possible way you can use Embabel. So if you just type this, you will see that it invented an animal named Luminar of species gleamwing serpent. And so here, just incredibly simple prompt specifying the type, and we're injecting an AI object. So when you have Embabel set up, anywhere if you want to add just a tiny little bit of AI to your application, you can get this AI object, which gives you the ability to call LLMs. So, you know,
So if I would be building an application and I would have like a particular injection point where I need to do something like a fuzzy computation, I would just, in my normal Spring Boot application, I can just add in Babel sorter and inject AI like this, and
yep,
sort of this is it.
yep,
This is awesome.
absolutely. Yeah,
Uh,
and I mean one of the really interesting use cases we've seen for this is where people literally are just filling in the gaps in existing applications. Like one of our customers is in the travel business, and one of the first things they've done is they have a form where if the user like fills in a free form text field, it used to have to go to a person. And so they're actually able to use a local source model, GPT OSS. So they completely control the deployment of that model and try to solve it just using this kind of, very simple. Yeah. So, not everything is a fancy agent. So our goal is to try to, cover things from the simplest to the more complex. Shall I go
right.
on to a more complex demo
Can,
using tools? Or
can I
should we?
can I ask can I ask about like designing the agents? So like there's like like a naive approach to creating agents, which is most of the demos you see will show. And this is how I think a lot of mind share how to create agentic applications look like this, right? So your agent is three things. It's an LLM, or like some sort of AI component. It is the system prompt, or like the actual description what your agent would do, and this is the collection of tools. We're gonna get to
Yep.
tools and how exactly to wire them in a bit, but so those three necessary things, and you can create useful things, right? Like you can glue those components together. You can say that is my LLM, that is my key. Go talk to it, and here's the prompt for you. You are a marketing persona, or you're a coder and you're helping with me with this particular task. So that is like at a high level could work, and potentially with the like genius level AI, you could solve any problem like that, probably. So when Babel takes a very different approach where you need to sort of give it actions, so you need to do some domain modeling. How would you how would you approach creating a system of agents, like, or maybe like a single agent, but with a more deterministic workflow using Embabel? Do you write the method signatures and then sort of fill the prompts, or do you start with the prompt? Like, what's your take on like how do you do this?
Okay, there's a lot of things there, and they're all great topics. So maybe to start off, yes, as you say, that is those three things are the default way people start. Now you can absolutely do that with Embabel. You can expose as many tools as you want. You can have a complex prompt. You can throw it at a model. You have that. We generally don't encourage that as the way to model whole applications, because the problem with that is you're going to have a large prompt, you're going to have a lot of tools. They're not going to be predictable how those tools are called by any model. And also, you are tied to a God model, right? Essentially, as you say, you want genius level AI to make this work. And that comes with a number of problems. Firstly, it comes with cost, it comes with latency. It also comes with the fact that in an enterprise, you don't control that model. Like your God model, literally, I mean, the model providers can break you overnight. I've had applications broken literally overnight by both OpenAI and Anthropic. So our view of the world is, firstly, you should assess what is it that you're building. So, for example, if you're building a coding agent, take Claude Code. Claude Code's great. Claude Code essentially does that, right? It's got a sophisticated way of rewriting its to-do list, but it gives a genius level AI a lot of tools and says, go figure out how to solve this problem. It works well most of the time, and it's probably the right approach to that problem. However, its failure rate is completely unacceptable for automating business applications, right? It is inherently not predictable. But nevertheless, for that particular scenario, it's quite good. On the other hand, you look at any business process that's going to surface directly in customer interactions. If Claude Code does something wrong, you just revert it and Git, right? Like you can see, oh, that's a bit off. Bye bye, it's gone. You can't really do that if you've had an interaction with your customer and you put something in front of them that was really wrong. In fact, I think Air Canada tried that a while ago when, they presented a wonderful quote fare to someone and then tried to take it back. So you need more predictability. So the goal with Embabel is to say whatever you want to do, you have the tools to do it. Like you want to write one call that has a ton of tools. We don't particularly recommend it, but sure, you can do it. But essentially, the development process, my experience has been that you learn as you go, and you start off typically with experimenting with some prompts. And in fact, for anything complex, I'd strongly recommend people try something like the OpenAI Playground or some of those tools, right? Like iterating on any code is slower than just iterating with prompts. So, prompts are important. You should start by, getting a sense. But then, depending on the level of predictability you want, work out how much you want to pull into the domain. Like one of the things we could do to directly illustrate this would be to jump to our travel planner demo, which is way more complex, but I think it's a great illustration of the kind of trade-offs around this. Should we do that?
Yeah, that's awesome. I'm
Yep.
sure we'll
Okay.
help
So
there as well.
this one is in the Tripper repo on Embabel. This one's actually written in Kotlin, but essentially Java or Kotlin are exactly the same. So let's have a look at the domain model we've got here, which is a little fancier. So we start off with a travel brief. So this is where the kind of thing people want to do and their departure and return dates. And we also know about travelers. And what we're going to pop out the end is this travel plan object. So there's a lot of structure here. So, for example, it's not free text. So, for example, it's not saying you will stay in Paris on Tuesday, you'll stay in Dijon on Wednesday. What it's doing is breaking it up, for example, in a list of stays. So, it also has access to the travelers, and it means that certain things we can put in code for greater predictability. So the richer your domain model becomes, the more you can work with code. So this has major benefits. So for example, let's suppose we have a rule that you cannot stay more than 4 nights in the one place. We just write that in code. We're not reliant on an LLM. Similarly, if we had rules that you cannot have to drive more than 600 kilometers in a day, we could write code for that. Just use Google Map calls. And so, there's a lot of benefits in your ability to make things predictable by working with code. The most impactful single one of this is the code that I've got highlighted. So when we run this, it's going to produce a Google Map link for the driving itinerary. Both Claude and OpenAI models think they can generate Google Map links, and they kind of can. But when you have a really long Google Map link, you just need one character off, and the whole thing doesn't work. So, I would say we were getting probably 85% failure when I was letting it do it. So instead, I just write this code using the domain structure that we have to calculate the link in code, and it has not failed since. So while we talk about this, let's actually run it. So it's got a simple HTMX web interface on it. This is really live. I'll leave it for the sake of time. I'll leave it the same samples. But so when we plan it, whoops, whoa, oh, that's because I'm not running the server. Okay, yep, it's a genuine example. Let's start the server. So this one obviously has a web stack on it. And it's using MCP tools because it's going to need Google search, Brave search. It's going to need Google mapping tools, and it's going to need an Airbnb tool. You're probably going to like where these tools come from because they come from Docker and the Docker Desktop MCP gateway. And, I think really this is a far superior alternative to, say, running tools with MPX or UV as individual processes. Like it used to handle secrets. Yeah. So that's all good. So the tools are accessed via MCP. You can see it's started up. And now hopefully it will look whoops. Oh, actually, okay. It did actually. Okay. So it's correctly submitting it. So let's go back here. We'll resize this. So this is a very simple interface to stream back events. As Embabel runs, it generates events. So you probably noticed the Star Wars logging before. It's both a bit of fun, but it also has a serious point that all info level logging comes from events, which means we can stream those events over something like SSE. So what our travel planner agent does is start off the very beginning. It uses a number of different models, by the way. So it starts off by finding points of interest. So it says, considering the following travel brief, and notice we're building this prompt in a type safe way, find points of interest that are relevant to the travelers. So here we're using a good LLM. I've externalized the LLM into YAML using Spring. So we can change this. For example, we want to change the persona of the planner. We want to set hyperparameters or everything all externalized. And we're giving it tools. So here again, you see that Fluent API you get from context.ai, very nice in either Java or Kotlin. So here we're specifying tools. We're saying we want web tools, we want map tools, and we want math tools. And we're using a good LLM. So if we look here at the Thinker LLM, it's GPT-4.1. So it's a full fat GPT 4.1. So once it's done that, it produces an itinerary ideas object. So one of the other things that I think makes a lot of sense with domain modeling is when you have these interim objects, because you can put guardrails on them, you can validate them, right? Again, the more domain model, the more structure you have, the more you understand what's going on. And obviously, understandability and explainability is one of the major challenges we face. So now we've got a list of points of interest in that object. So that takes us to the next action, and the planner can work all of this out from the types, the flow of data types. And so it researches points of interest. So here you can see it firstly specifies a prompt runner, which has got the requisite tools that it needs. And now it uses the operation context parallel map method. So it says, hey, you can run this in parallel, but don't have more than a certain degree of concurrency. Very important to control that, because you're not really going to run out of virtual threads on your JVM, but you are, if you do it too fast, you're going to get rate limited. And that will be a great deal slower if you're backing off and waiting for the model to be rate limited. So here we're using a different LLM. So here you can see that we're using the researcher LLM. Let's have a look at the researcher LLM. It's GPT-4.1 mini. So, another good example here that you use the appropriate LLM for the call. This is a short prompt. All it has to do is a little bit of tool calling, doesn't have to think of any wonderful ideas. So once we've got that, we now have points of interest findings. Now we use a good model again. The Rider LLM is a good model, and it takes all of that and builds a proposed travel plan. Next step is it finds places to sleep. So it looks at the days we're staying, and for each of those, it uses the Airbnb tool to see Airbnb locations. So here is what it output: from Roman stones to wine thrones. So we should have a link to the interactive map. And guess what? The interactive map actually works because it was built in code, and there aren't any funny characters there. So we've used image search to find places along the way. We've written it up, and then also we've got our Airbnb links, which should be for the correct. Oh no, that actually is wrong. There is a bug in that prompt, I think. By a whole lot of this was coordinated through data types and is therefore very testable. What else was I going to say? Oh, yes, there's some post-processing at the end. The post-processing at the end involves LLMs love hallucinating images. I don't know why both OpenAI models and Anthropic models love hallucinating images. What we do is a final pass where we look at every image, run an HTTP GET on it, and if it doesn't exist, we just quietly delete it. So, again, you need these kind of workarounds in code. So does that make sense?
Yes. I think I need to sleep on this and maybe play with it a little bit more. I don't fully understand. It feels that there should be value in building the plan by the planning approach, rather than then writing it in code. Because for a task like here, there is only one natural way to connect the actions, and that what normally I would say in the method, right? I would say find points of interest, do this, do that, chain that via just variables passing back and forth. And I'm sure there are like many use cases where this non-deterministic planning and retrying and replanning is essential. Probably not in a simple example like this. Uh, it feels very powerful, but it also feels like like I'm a little too inexperienced to appreciate that. Um,
Well, I think we did jump from a simple example to a fairly complex example. So there
no,
is a lot to,
yeah, it is awesome to see such a complex thing in action. It is a very comprehensive example. I think one of the best where you actually connect to external systems. Like no way an LLM would actually guess that Google Maps link correctly. Like no
yeah,
chance,
I would, yeah.
100%. And it's a very nice example because a lot of data in the real world is actually super important. Like if you pass
Mm.
like an
Yeah.
IBAN for the bank account, right? Every number
Yeah.
actually is very significant, right?
Yeah,
Believe it
well,
or not.
actually, interestingly, in terms of making it more reliable, the Airbnb link is the only thing that is a bit flaky at the moment. The reason for that is that I'm using an Airbnb tool. So an LLM is calling that because I don't think Airbnb have an API I could call in code. So I could make that 100% reliable if Airbnb had an API that I could call in code. So, it is actually the one flaw in the application is actually a demonstration of the limits of tool calling. Because, yeah, I've looked at that prompt. It looks fine to me. I've debugged it. It's sending the correct prompt. And often it gets the tool call just a little bit wrong. And, then you end up in Nashville instead of in France. Um,
Well,
so, yeah.
yeah, as for most things, you probably need to have some human in the loop at least at the end of this. So hopefully you're not gonna book this holiday travel plan and then just go without looking. No, this is awesome. This I feel as a Java developer myself, I feel this is very approachable. Uh, I think I understand better your idea about how to create a system of agents using the actions and goals. That was a very high level thing that I didn't grasp before. So thank you. This was very, very educational for me personally. Uh, maybe one of the last questions. Uh, do you see like so Embabel is a few months old now, right? So you've been working for some time on this, and in the AI ecosystem, time goes even faster than in JavaScript, right? It's just
Yeah.
that's
Yeah.
since the beginning of this year, it's forever in AI years. Uh, do you see ideas from Embabel sort of uh, start being adopted, or do people in the ecosystem take notice, or uh, is everyone building their own things and not particularly uh, looking for inspiration?
Look, I think there currently is probably not as much awareness as there should be of what's happening on the JVM ecosystem, say in the Python ecosystem. I think that the domain modeling, my emphasis on domain modeling, I think that is starting to get more awareness now. So yeah, I think the ideas hopefully will cross pollinate. I mean, certainly I'm very familiar with all the Python frameworks. Uh, I I'm not sure that I've learnt that much from them, but well, actually, that's maybe a little harsh. But frankly, I would say that if you look at the approaches to planning in Python, they are the obvious things. Like, if you think about this problem of how do you plan multi-agent workflows for, 10 minutes, and you haven't thought of this finite state machine, you haven't thought of sequential nested execution like Crew AI, and you haven't thought about using an LLM to plan like, um, semantic kernel, you're probably not a serious computer scientist. So, what I would say is that I think there's a significant advantage in not being first mover. Look, I think that understandably, a lot of the Python frameworks ran with the obvious things. And rather than, whereas, I kind of had, I don't know if I'd call it the luxury because it was kind of also sometimes frustrating. I spent a lot of time thinking, okay, is there a better way? And maybe, sometimes not being first mover is a considerable advantage. Like if you look at Spring. So, obviously I was pretty well known to have a low opinion of EJB. The fact is, though, that if EJB had not come before Spring would not have been as good. So we took ideas like declarative transaction management was a really good idea. Admittedly, it wasn't originated in EJB, but we did the same things where they'd done things that were good, and we learnt from the things that they'd done that were not good. So often to get to a really good model, it's important to see what's out there.
Yeah, that's a true Java way, actually. Like that's how the whole language and the platform operates and moves forward.
Yeah,
Taking their sweet time to achieve there, but
yeah.
the results are super impressive. So,
The whole
uh,
question about like the space of time is really interesting. And obviously it has accelerated a lot in so for example, some of the first wave of frameworks in Python, like for example, LangChain, still has some legacy in terms of its design from pre-tool calling being a thing. Right. Like, so, capabilities of models have definitely improved. But interestingly, there still is momentum. Like you look at LangChain, which is really quite dominant in Python. And the fact that LangChain, developed traction is stickier than you would think, even despite things having accelerated. What we're trying to do is progress to 1.0 fairly rapidly, but we understand that you can't, like, it's different from, say, doing a release of Spring, right? You've got to get to market quickly, you've got to follow features quickly. So we differentiate between stable and experimental features. So when we do 1.0 final, which we hopefully will by the end of the year, there will definitely be types and methods in there that are annotated with the JetBrains at API status experimental. And we think that's a really nice balance. So, when we ship 1.0, if you don't get any warnings in your IDE about using experimental features, we'll do our utmost not to break your code. But on the other hand, there will be extra stuff that's not yet baked, and you will be able to give us feedback on it. Hopefully, it will work to the benefit of everyone.
right. What's the best way to connect with the Embabel community and give feedback and learn?
The Discord is pretty good. So the link to Discord is on the repo, the agent repo. And also, obviously raise issues, discussions, pull requests. We, getting some really quite good community engagement. We've got quite a number of community contributors. We've got people translating resources into different languages, also people making, material code improvements.
Yes, that is awesome. That's the power of open source.
It
Great
is.
to hear.
It is pretty amazing. I mean, I haven't done so really most of what I've done in the last probably 15 years since GitHub really became a thing was not actively developed open source. I mean, some of it was open source, but it wasn't open source to the big community. And that is actually pretty satisfying to feel that rush again and also do it with like so much better tools. In the early Spring era, we were using SourceForge and CVS. Admittedly, we switched off CVS pretty quickly, but it's just amazing to do this with the
Yeah,
kind of tools we have for community now.
yeah, yeah. Just to wait until AI will get good at coding, and then you won't even need to. I'm ki-
This is already an issue. Like we are getting like overall the community contributions are great, but we do get some things that are very obviously AI generated and where the contributor probably didn't really understand them. And like every active open source project I talk about is dealing with this. So we actually are planning to develop community agents that help us manage, like GitHub, and because, yeah, unfortunately, probably the only defense against people making pull requests with bots is having bots to triage them.
Yeah, as it was everything, the answer to problems with AI is more AI.
Right. Yep.
Which is,
It's good if
uh,
you're a model vendor. You can lose money even faster. Yeah. So,
excellent. Thank you so much. This was very, very insightful. I learned a ton. I'm sure our viewers learned a lot. Uh, check out the sample agents. Check out the Embabel. It's Java. It's Spring Boot. If you are in Java ecosystem, it will feel very, very natural for you. You can plug it into your existing applications making use of your domain model, existing classes. Just see how it feels. Or you can create from scratch, just for example, using the agent template as Rod showed. So thank you for watching and stay tuned for the next episode.
great. Thank you
Thank
very
you
much.
so much.